Alright, hello everyone. My name is Justin Shu, and this is my Physics 2 Lab 1 on the charged tape. So, as an introduction, the purpose of this lab is to observe the abstract principles of charge and electric fields in interactions with pieces of plastic tape. And so the main physics principles that we'll use for this lab are the electric force and field, Coulomb's law, which goes with that, and gravitational force, which also goes with the F equals ma, which we will use in the future as F equals mg for the gravitational acceleration. And we modeled each tape as having a single net point charge concentrated at its center, and for the results of this lab in finding the tape's charge as well as the electrons transferred to the tape, or from the tape to another piece of tape, those are these two numbers seen below. But moving forward here with the lab details and how it was conducted, as you can see, we have two pieces of tape here, and we rapidly rip off each of those pieces of tape from the base tape, which will transfer electrons from these two pieces of tape to the base tape, making both tapes positively charged. And these are some of our starting metrics for this experiment. But then moving forward now to the calculations, we first found the mass of the tape or estimated it, and then from there we multiplied the mass by the gravitational acceleration to find the force downward, and then from there equated that to the electric force at which it will kind of bring the top tape out of equilibrium, which is what we were looking for. And so from there we calculated or isolated Q, and then calculated that to be this number in coulombs. And then finally, we calculated the amount of electrons that were transferred in dividing this charge by the charge of an electron, right? So the main experiment here was just holding up one piece of tape to the other, both of which were positively charged, and seeing perhaps what was the charge on the tape as well as the electrons transferred from the tape in the interaction between the two tapes, which they repel each other. And so for my computational model, it's seen right here in Python. I have all my starting metrics here, and then from there plug it in as I kind of described before within Python, and then visualize it with vectors. Seeing here there's two different charges, and I can model the vectors on the top charge. And here are the values as well in the experiment. Then moving forward here to our lab assumptions and room for error, we kind of assume the charge on the tape is only at the center of it, and that the tape is a point charge. But in reality, the tape could have a mass. The tape could, be not uniformly charged, so that would cause some level of differentiation, right? And then also too, assuming the horizontal forces are negligible here in the interaction between the tapes, as you can see from the web Python and from our calculations, we only really worried about the vertical components of a force. And finally, we assume other external forces such as air resistance, friction, are all zero, right? And that the system is isolated, which actually may not be the case. And then finally, for the what if and what does it mean questions, here if we were to kind of switch electrons to positive charge and protons to negative charge, nothing would really change with our calculations, as two negatives make a positive inside the Coulomb's law equation. The only thing that would really change is the naming of the two charges, right? And then finally, why is it important to hand out the charged tapes as little as possible? And what happens when charged tapes come into contact with other objects? Well, that would cause electrons to transfer from the tape to the other objects, partially or fully neutralizing the tape. And we had to actually redo the experiment a couple of times just to make sure we had accurate numbers here. But that's really it, and thank you so much for listening.